น่าจะเหลือพอให้เด็กได้แต่ว่าเด็กเรามีเยอะนะถ้าลงทะเบียนก็ถ้าแห่กันลงหมดนี่ก็น่าจะไม่ได้นั่นไม่ได้ครบหรอกนะแต่ว่าก็ลองดูแล้วกันนะครับเพราะถ้าลงได้ก็คือได้ก็น่าจะเร็วอยู่นะฮัลโหลจิมมะ
Hello sir.
Okay, you must work hard because you register the DSP right in the same time. Okay, by the special case. Okay.
Yes sir.
Hi, Abdul. Up.
I'm here, sir.
Okay. Submit the homework. Okay. Only maybe 1, 2, 3, 4, 5, 6. Maybe only 6 students is submit the homework. I give you only 1 minute for submit the homework. Okay. If you cannot do it, don't worry about that. I will provide your solution. Okay, complete solution and try to study from the detailed solution. Okay, how to find them, how to integrate them. Okay. Now, hello, what did we all? Yeah. How many times? 2.
Yes, sir.
Okay. I give you only 1 minute. Okay, during this time, I provide your solution. You can see my slide.
Yes.
Okay, the first question is here. Okay, you integrate this function. The function is psi minus 3t multiply with the delta function. Okay, the impulse function. Okay, from this formula, you can see that the size minus 3t is the Pink's function ft. Okay, you can see them to be the ft. You integrate them. Okay, therefore from the closed form equation, you integrate ft minus t naught multiply with the delta function is equal to f minus t naught. F minus t naught is here. Okay, minus t naught is minus. Okay, in this case, is the time is not shifting. Okay, therefore the sign minus 3 at the time equal to 0. In this case, t naught equal to 0. Okay, sine 0 give you 0. Sine 0 give you 0. Therefore, in this case, you multiply them. The result is here. You multiply sine with the delta function and you integrate from infinity to infinity. Yeah. The result equal to 0. The second one is a little bit more complicated. Okay, a little bit more complicated. In this case, t naught. Okay, t naught equal to. Okay, t naught equal to 4. T naught equal to 4. Okay, therefore sine minus 3 at t naught equal to minus at the minus 4 is give you here. It becomes to be sine minus 12. Sine minus 12 equal to 0.54 approximately. Okay, we use this formula almost all. Okay, now in this case it's a little bit more complicated if f is a time shifting by t naught and the impulse is the impulse function is a shifting by t1. The result from this integration between f and the impulse function equal to f minus t naught plus t1. Okay, t naught equal to 4 and the t1 equal to minus 4. Okay, it's here. 4 minus 4 give you size 0. Give you size 0. Therefore, this integration between the sine function and the impulse function give you 0 for this case. The next one is the same, okay? The shift between two of them, okay? T naught, okay, equal to 1, and T1 becomes, okay, equal to -2, okay? Equal to -2. Substitute them in this case, okay? In the bracket, -2 and -1 and -2 become -3. Multiply them, give you here 3 and multiply that, okay? Next one, for the sign, multiply between sign and the impulse function again and shift, okay, T0 and T1. The result, okay, is become to be -1 and -2. Okay, multiply them, give you, and this case, you will scale them too. Okay, scale by 0.5. Okay, because this factor. Okay, the result give you here. Last one is this is for the next one. Okay, the next question that I will order you to do in the next time. Okay. The detail of the integration you will do and solve them by yourself soon. And yeah, yes, okay. Step is one of the very important step. Okay. In the previous, it's only analyze some basics question of the impulse function and the unit step function. You can find them in the signal system textbook, or maybe find them from the EE-Math textbook more. Okay, I think everyone already passed EE-Math. Okay, but you may be not too familiar in the impulse function or the unit step function clearly. Okay, next step we concentrate on the mathematical function for the signal. For the mathematical function for the signal, we have two steps. Okay, the first one you can write. Okay, you can plot the graph from the math equation, or you can extract the equation from the graph. Okay, it have two steps. Okay, it have two process. Okay, you have equation, you have the graph. You have the graph, you write the equation. Okay, from the mathematical analysis point of view. Okay, you have the equation, you get the graph is more easier. Okay, and if you have the graph to extract the equation, it's a little bit more complicated. Therefore, in this section, we separate them in two steps. The first one, I will give you the equation first, give you the equation and teach you how to write the graph from this equation. Okay, I will show you in the real example. Okay, when you see, okay, when you find the function or the equation here, ft equal to 3 ut plus t ut is here. Okay, you separate each term, make them to be a simple term. Okay, the simple term can split by plus or subtraction operator, addition or the subtraction operator. Okay, in this case, you can see that this is the first term, this is the second term, this is the third term, and the last term. Therefore, in this case, the function ft can be separated into 4 simple functions. Okay, the green one. Okay, the green one. Okay, can you see the slide? The green one is here. Okay, tut. T is amplitude scaling. Okay, amplitude scaling. You get ut first. Okay, in order to make you more understand, I will get them in the whiteboard. Okay, step by step. Okay, can you see the whiteboard? Hello, can you see? Can you hear me?
Yeah, we can see it, Sean.
Okay. The first graph is ut, right? The first function is 3 ut. You must get ut first. What about the ut? ut is the unit step function, right? Okay, I can get in here. Ut is here, right? Ut. For time less than 0, it equal to 0. Time greater than 0, it equal to, okay, ut. Okay, it equal to 1. Okay, 3ut is mean for this case is the amplitude scaling. You scale, you amplify the signal by 3, right? Expand the signal 3 times. Therefore, 3 multiplied 0 give you 0. Okay. Yeah. 3 multiplied 1 give you 3. Okay. Therefore, the graph will become here. Okay. This is a 3ut. Okay. Can you see that? Where it came from? Okay. This is the first one, first piece. Okay. Now, for the next one, okay. The next one is here. Okay. This is the first element. The second is TUT. Okay. The second term is TUT. Okay. We get, you know how to multiply between two graphs. Okay. First one T, second one UT. Okay. We concentrate on the UT first. Okay. For the UT, for time less than 0, it equal to 0. Time greater than 0, it equal to 1. UT is here. Okay. For the second term T, okay, you can plot that T is very easy. Okay. If it is 0, 0. T equal to 0, it equal to 0. T equal to 1, it equal to 1. T equal to 2, it equal to 2, and so on. Straightforward. Okay. Straight line. Okay. Now you multiply between the blue and the red one. 0 multiply anything give you 0. Okay. 0 multiply anything give you 0. Okay. For time greater than 0, the blue graph is 1. 1 multiply anything give you that thing, right? That thing, it will become here. Therefore, the result of this graph is about here. It's about here. See that? This is a T, UT. Okay. This is for the second piece of the graph. Okay. Now, okay. Next one. Next one. This is the second piece of the graph. Okay. I will show you all each piece of them. Okay. Okay. Next one is here. Okay. Next term is minus T minus 1 U T minus 1. Okay. In fact, you can see that it's very close to, it may be derived from T UT, right? But every T you shift by 1. Okay. Therefore, in this graph, it still belongs to TUT graph. But you process to time transform. You process for amplitude reversal and time shifting. Okay. Amplitude reversal and time shifting. TUT that we get in the previous step, okay, it can get in here. I will show, I can write this graph maybe in the blue one, okay, TUT. You know where it came from and why, okay. This is TUT. Sorry. Okay. Okay. In this case, you must take the amplitude reversal first, and you take the amplitude shifting after that. Okay. For the amplitude reversal, okay, you flip. Okay, you flip respect to horizontal axis. Okay, the flip graph will become here. Okay, this thing, right? Minus T UT. Okay. And next step, you shift by 1, right? You shift every class by 1. In this case, it's already in the general form of the signal transform. Okay. X t minus t naught. Therefore, in this case, t naught equal to 1. T naught equal to 1. It means you shift in the right hand side of this graph by 1 point. 1 point. You shift them 1 point. Okay. This graph is minus t, yeah, minus 1, u, t minus 1. Okay. The overcloud graph is the red one. Okay. For the summary, you get here. Here you get the red graph. Okay, you get the red graph. Okay. And the last step is the similarity pattern. Okay. I think you can. Yes, I will show you all point of view again. Yeah. The green one is here. 3U3. You know how to sketch each part. Okay. To sketch each part. 3UT. Okay. Here is UT. You amplify them. You use the times scaling by 3. Okay. Second one, TUT. TUT is here. Okay. The orange one. Okay. Next step is the pink one that we just compute. Okay. Minus t minus 1. UT minus 1. Where and why is have this pattern, is have this portrait is here. Okay. The pink one. And 5 minus 5 ut minus 1. You can see that this graph is modified from unit step. Okay. You take, okay, the amplitude scaling, amplitude reversal, and time shifting. The graph that you get is a blue one. Okay. Here is a unit step. Okay. You take the amplitude reversal and the amplitude scaling by this step. Okay. And you take time shifting in the right hand side by 2 points. Now, after you get this graph, you add every graph together. You add every graph together. During you adding, it's a little bit confused. Therefore, I will adding for you. I will process the detail of the adding the graph to you again, another one time. And why it belong to this graph. Yeah. Try to see that, because I think it's a little bit more complicated. If you try to do by yourself without your understanding, it's difficult to find the graph, the correct one. Okay. Yeah. Yeah. You adding the graph. Okay. 1, 2, 3, 4, 5. Okay. Okay. Now we get the old graph first. Okay. Wait a minute. The green one is here. Okay. The orange one. The orange one. Okay, we use the dust. Okay, this graph is 3U3. Okay, the red graph is TUT. Okay, and the pink graph we use. about that. Okay, the last one is the blue. Blue means song. Okay. Can you see this? Can you see my whiteboard?
Yes.
Okay, at this step, okay. Now, we maybe use, okay, the magenta instead here. Okay, we cut. Right, I told you before, when you try to add things, okay, the signal, cut them in each piece, okay, in each straight line, okay. Okay, for time less than 0, okay, you cut between here, okay, inside them, okay, inside them, inside this point. For example, we start from -1 to 0, okay. Instead, you consider about at the time equal to -1 exactly. No, no, no. You consider them at the time 0.999, okay, a little bit one. It's close to this point, okay. At this point, okay, we consider them, okay, and 0 instead we consider at the time equal to 0 exactly. No, we consider at the time equal to maybe minus 0.0001, something like that. Okay, something like that. Okay, now we consider the red. At this point, the red equal to 0, right? The red equal to 0. Okay. Okay. Close to this, the red is 0 too. Okay. The green, 0. Okay. This green is a 0. 0, 0. Okay. Okay. The next one, the blue is a 0. 0. Okay. The blue is a 0. Okay. And the pink one, maybe here. Okay. 0, 0. You adding them. 0 as 0 as 0 as 0 give you 0. 0 as 0 as 0 as 0 give you 0. Therefore, the final graph that you get is here, 0 and 0 here. Okay. Okay. We can use the highlights link between them. Okay. 0. Okay. Next one in the next step. Okay. In the next step is here. Okay. We consider at the time is here. At the time go to this point a little bit and this point a little bit. This thing is time equal to 0.0001 and the time equal to 0.99999. Okay, something like that. One. Okay. Now at this point, you can see that what about the red is? If it equal to 0, you don't know what about the exactly the green is, right? Green may be 0 or maybe 1, right? But when the time equal to 0.00001, okay, something like that, very small one, but greater than 0. Okay, at this point, the green is very clear. Okay, it equal to 1. It equal to 1. At this point, the green is equal to 1. Okay, you can see that if we don't shift them a little bit, okay, inside the boundary exactly. If you use at the boundary value exactly, you don't know what about the green is, and it's difficult to compute. Okay, next one. Okay, now we consider the red one. The red one at this point. The red one at this point is okay. At the time we go to close to 0, we get 0. Okay, get 0. And this point, okay, due to the unit t ut, okay, is equal to 1. It equal to 1. Okay, it equal to 1. If so the graph may be not exactly in the scaling. Okay, if you draw by yourself, you use the table. Okay, you can make them more scaling than that. I use the Microsoft mouse and try to sketch it to you because I think it's very important to you. Okay, next one. Okay, the next one is okay. The pink one graph is here. The pink one is still 0 and 0. The blue is still 0 and 0. Oh, sorry. This thing is not, okay. This 3, not, sorry. This not 1, sorry. This 3, right? The green is equal to 3, not 1, sorry. Okay. When you adding them, okay. When you adding them, 3 as 0, as 0, as 0, give you 3. Okay. 3 at 1 as 0, as 0, give you 4. Okay. You plot them. The result is equal to 3 and 4. Okay, 3 and 4. The graph is here. The graph is here. Okay, between the first zone and the second zone, you link between the last point. Okay, here. Okay, at time equal to 0 minus, it get 0. Okay, at time equal to 0 plus, it equal to 3. Link between them. Okay. Now for the next one, okay, we compute them more. Okay, inside here, at this point and at this point, the green equal to 3 again. Okay, and the 3 equal to, okay, the green gap at time equal to 1, it equal to 3, and time equal to 2, it equal to 3. Okay. Okay. Next one is here and is here. Okay. This thing is equal to 1 and it equal to 2. Approximately that. Okay. And this thing, okay, the next graph, the pink one. Now the pink one is start the effects on this case. Okay. The pink one is have at this point it equal to 0. But at this point it equal to 1. Due to the graph is minus t minus 1 u t minus 1. Okay. And for the blue is still not fx here. It's 0 and it's still 0 again. 0 and 0 again. Okay. This thing is minus, sorry. It's minus. Okay. Therefore, 0 as 3 as with 1 as 0 and as 0 give you 4. 3 at 2 minus 1 give you 4. Okay. Therefore, the graph at this point equal to 4 and 4. Yeah. Okay. Now for the last zone. For the last zone is here. The green equal to 0 and 0. Okay. The green equal to 0. Oh, sorry. Equal to 3 and 3. Sorry. 3 and 3. Okay. Okay. For the red one. Okay. The red one is here from this not exactly plotting. Okay, it equal to 2 and 3. Okay, for the pink graph, it equal to minus 1, minus 2. Okay, and the blue is now is effect because it equal to minus 5. Okay, 3, 2, minus 1, minus 5. The total result equal to minus 1. 3, 3, minus 2, minus 5 give you minus 1. Okay, give you minus 1. Whatever the graph is drop to here and drop to here immediately. Okay, and here. Okay, and so on. Okay, this is the detail of the computation. Okay, now I will show you in the animation point of view in the Microsoft PowerPoint to see you in the overall. Okay, the green 3u3. Okay, you know where it came from. T, okay, 3u3 minus t minus 1, ut minus 1, and minus 5, u minus t minus 2. Okay, here. When you adding, you add each piece of the club. You separate the club in each zone. The first one is a 0. You know why it's 0. Okay, the second one is become to be 3 and 4. Okay, and the next one is straight line between 4 and 4. And the last one is dropped to be minus 1 and here. You will know where it came from, why the red club is came from. Okay, how to compute the red club of the green, the orange, the pink, and the blue one. Okay, in the my whiteboard detail. Okay, you can see that. Now for the conclusion, this technique you can use in all. Okay, separate the club. Okay, separate the mathematical function into a simple one. How to split them? You split them into by using addition or the subtraction operator. Okay, if it multiply them, not necessarily to extract them. Okay, using them in the whole piece. Okay, TUT multiply them is the same function. Okay, t minus 1 ut minus 1 is the same function. Okay, 5 ut minus 2 is the same function. Not you don't necessarily to separate 5 and the ut minus 5 so on. And for each term, okay, the green one you process, you compute them from the ut by use the time transform that I teach you in the first class. Okay, tut the same transform. Okay, minus t minus 1 tut minus 1 is a time shifting and the amplitude reversal. Okay, and the last one is require the skill of the the amplitude reversal, amplitude scaling by 5, and time shifting by 2. Okay, you get the pink graph, the blue graph, the green graph, and the orange graph. In the final step, you cut the signal in each piece. Okay, how to cut them? How many pieces you cut them? Okay, if okay, you can see that if we change the slope, okay, cut them at that point. You add things between that. Okay, if we change the value suddenly, cut them. Okay, if we change the value suddenly, cut them. You cut them in this case. You will cut them into 1, 2, 3, and 4 pieces. Okay, 1, 2, 3, and 4 pieces. You will get 4 piece straight line. Okay, 4 piece straight line combined together. Okay, you can see that when it's get. Okay, we draw only during this part. How to connect between the first part and the second part. Okay, you only link them. Okay, you only draw them. Okay. Now, for the first one is already finished. Okay, the next one is more complicated than the previous one. Okay, if you have the mathematical graph, for example, this graph you observe from the oscilloscope or from your meter. Okay, you want like to analyze them by apply them by use them in analyze the mathematics equation. For example, you would like to determine the Fourier transform of this graph. It is impossible to push the graph into the equation, right? You must write them in the mathematics or equation form first. Okay, how to write them? Okay, the same as idea. Okay, in the previous, before we sketch them, you separate the graph in each simple term. Okay, now in this case, if you would like to sketch or to express the mathematical graph into the equation, okay, you will split them first, cut them in each piece. How to cut them? Okay, how to you see that? Okay, if you checking that how many terms you have, you cut them. If it have changed the slope suddenly or change the if it change the slope or change the value suddenly. Okay, two things: change the slope or change the value. Okay, in this case, it change the value, right? It change the slope from slope 0 to be slope equal to 3. Okay, cut them in each bit, the first bit. Okay, and this point, it change the slope from 3 to -3. Cut them again. Okay, and this step, okay, the slope equal to -3 to be 0. Change them again. Okay, another one term. Cut them. And this, okay, change the value from -3 to be 0, you cut them again. After you cut them, okay, you cut them, we split them in each piece, okay. You draw the mathematical function for that case, okay. The detail of drawing, okay, I will write them in the, okay, the whiteboard again to give you more understand about that, okay, and in the detail. Yeah, okay. Okay, the first time if the club is here, okay, if the original club is here 0 and -1, sorry, -2, okay. Okay, about this, okay, okay. Okay, in this case, okay, can you hear me?
Yes.
Okay. We cut the club in each term. Okay, if we change, okay, change the value is required one term in here. This is required the second term. Okay, yeah. At this point, the slope don't change and the value of them is don't change. You cut them during this time. Okay, they change the slope. Okay, it's required one term. They change the value is required one term. Now, for the first term is here. The first term is very easy. Okay, the first term is here. Okay, we analyze the first term first. Okay, for the first term, okay, the graph will be in this point. Three, okay, okay, change the value at 1 and 2, right? This graph, the thing that we interest, you know, okay, when you see this graph, you can see that, okay, you know about, you don't know this graph exactly, but you know the graph that has closely common characteristic here, right? This graph is, okay, at 1 and 1, okay. This graph is TUT. Okay, this graph is TUT. Now, the thing is different is here. You can see that this graph is change the slope, right? During this period, okay, during this period, the slope equal to 0. Okay, the slope equal to 0, the flat graph. During this period, okay, the slope equal to delta y divided by delta x, right? Okay, delta y equal to 3, delta x equal to 1. The slope of this period equal to 3. Okay, you can see that the slope equal to 0, the slope equal to 3. Okay, okay, in this step, okay, the news, okay, okay, this graph will be modified from TUT. But what about the slope is? The slope equal to the new slope subtract with the old slope. Okay, new slope is 3, subtract with the old slope is 0. Okay, subtract with the old slope. Okay, therefore it's only that. Okay, TUT. Okay, yes, is it infinite? No, because the point of this graph is shifting from the center, right? It's shifting in the left hand side. Okay, therefore if it's shifting in the left hand side, it means you must shifting from the time shifting t minus t naught, right? If t naught is negative, in this case t naught equal to minus 2. It's shifting by minus 2. Okay, you replace, okay, plus 2. You change t to be here. Every 3 to be 3 plus 2. Okay, every 3 to be 3 plus 2. Okay, therefore the first graph will become 3 t plus 2 u t plus 2. Okay, to model this graph exactly. You know where it came from, where 3 came from, y plus 2 is came from. Okay, clear? Now, this is the first piece of this graph, the first piece. Okay, remember this. Okay, this is the first one. Okay, the first piece. Okay, 3 t plus 2 u 3 plus 2. Okay, now we go to the next one. Okay, the second piece. Okay, now we can handle for this piece clearly. Okay, we go to the second piece. Okay, when the graph is change the slope from here, okay, change from here to be here. How it changing? Okay, the new slope is, okay, the new graph is here. The new graph is here. Okay, sorry, minus 1 is here. Okay, okay, this piece. Okay, the old graph, the slope equal to 3 from here. Okay, now the new graph, what about the slope is? The slope is delta y divided by delta x again. Okay, but slope is negative, right? Delta y equal to minus 3. It changed from 3 to be, okay, 0 here. Divide by 1, give you minus 3. The new slope equal to minus 3. Okay, minus 3. The same idea. If it's straight line, you can use, okay, you can use the unit step function and the t function together. Okay, you know about the simple graph is here. Okay, but this slope is positive, right? It's t ut. Okay, but in this case, the difference between the current slope and now this slope, okay, here, okay, the current slope subtract with the old slope. The current slope equal to minus 3. Subtract with the old slope, subtract 3. Okay, therefore this term is become minus 6. Okay, minus 6. Okay, and the point that changing located at here, right? The point that changing located at this term t. If it's changing as is don't changing at t not equal to 0. It's changing at t not equal to 1. Okay, in the left hand. Okay, you're changing to be -1. Sorry, -1. Okay, substitute every t to be t minus t naught again, and you substitute to -1. Okay, it become 3 plus 1. Okay, change every t to be t plus 1. Okay, therefore in the overall point of view, the final function, the second term equal to -6. Okay, 3 plus 1. Okay, multiply with u t plus 1. This is the second term. Okay, add in the second term. Okay, therefore the second term equal to -6. Okay, 3 plus 1 u 3 plus 1. Okay, now for the next part. Okay, for the next part, okay, the graph is already changing the slope from 3 to be from -3 to be 0. 0, right? The flat graph, the slope is the 0. Okay, therefore we use the unit step function again. Okay, the graph is changing the slope during this period. Okay, we use the same techniques. Okay, we have t. Oh, sorry. Okay. We have t ut. Okay, the slope of them depend on the current slope. The current slope is 0. Subtract with the previous slope. The previous slope is equal to -3. Okay, subtract with -3. Okay, t u t. Okay, next step, you substitute every t by this point of changing. The point that changing equal to 1, right? 1 is mean and not equal to 1. Change. Okay, you change from 3 to be t minus t naught. And in this case, t naught equal to 1. Therefore, changing from t to be t minus 1. Okay, every point, at every point of t. Okay, now in the overall point of view, you get +3. Okay, t minus 1 u t minus 1. Okay, you get the third graph. Now, if it don't change the slope, but it change only the value suddenly, but the slope is still the same. You can see that the third region is the final region is slope is a 0, the same as, but it changed the value suddenly from okay, yes, from -3 to 0. Okay, if it change the value suddenly, it's very simple. It's don't use TUT, it use only UT. Okay, if it change the value only, it plus with the UT function, but you must use a little bit transform. Okay, a little bit transform. Okay, now in this case, the first step is okay, you take 2 things in this step. The first one, the constant that it changed. Okay, if it changed in the positive, is here the previous value equal to -3. Okay, the now it equal to 0. Okay, therefore the is magnified by 0, subtract with the previous one, the previous value. Okay, and multiply with ut. Okay, ut. In this case, the changing locate exactly at time equal to 3. At time equal to 3. Okay, substitute every t to be t minus t naught. Use the time shifting. It become 3 minus. Sorry, 3. Okay, at time equal to 3. Okay, substitute every t to be 3 minus 3. Okay, the final answer is here. Okay, it become 3 u 3 minus 3. The last term. Okay, the last term. And you link between them. Okay. Now to see in the overall detail. Okay. To see in the overall detail, I will show you in this step by step. Okay. After you know how to compute in the detail step, okay, the first step where it came from, why this club came from, how to compute them is here. The green one is extract from the first piece. Okay. 3 ut plus 2 and 2. Okay. Next one, okay, changing the value at time equal to -1. Okay, is here minus 6t plus 1 and ut plus 1. Okay. Next step, you changing the slope again at time equal to 1 second. Okay, this term is 3 t minus 1 ut minus 1. And the last one, it change only the value. Okay, at this point, it require only the unit step function 3 u t minus 3. Okay, therefore, in this graphical point of view, you can extract to be the mathematical point of view from this slide. Okay, I think combined with the slide and the detail that I explained in the whiteboard in the very detail, okay, you will know how to compute each term clearly. Okay, and this graph will be sketch this term more. Okay, you can see that whatever the real green is, the real green is here. Okay, the orange is here. Okay, the pink is here and the blue is here. Okay, and you can adding them. Okay, from that step point of view. Okay. Now it's your turn. You can see it's the quit in the exercise in the slide. Hello, you are here?
Yes. Yes, sir.
Okay. Take the exercise. Okay. You can see in the book the question. Wait a minute. The question 20. The question 20. Okay. Okay, I'm still here. If you have any question, you can ask me. But I think I teach you in every detail. Okay. Hello, no one finished yet? Can you hear me? Hello
ครับอาจารย์
เสร็จกันหรือยัง
ใกล้แล้วครับผม
The time is almost end, okay, and no one is finished yet. Therefore, I will assign only 2 questions to you, okay? Practice 20 and 21, okay? And the next time I will provide your solution, okay? The detailed solution, okay? To checking that the thing that you, okay, your answer is right or wrong. Okay? Any question? I think in this class, I teach you in the detail, okay? Remember that this book is only comprised from the PowerPoint, therefore it's maybe not provide you in all point detail, okay? In all topic detail, okay? In some topic, maybe, for example, in this topic, it's give you only 2 slides, okay? Two page, okay? And the detail to the construction is not right in the detail, but it fulfilled by you listen the lecture, see the slide in the whiteboard or so on, okay? Now I think it's already give you the, okay, the complete detail for this section, okay? See you next time, okay? Any question?
โตครับ
Okay, see you next time. คุณละ
2 ข้อนี้การบ้านใช่ไหมอาจารย์
ใช่ 2 ข้อนี้การบ้านส่งครั้งหน้าตอนเริ่มคลาสก็ทยอยส่ง5 นาที 3 นาที 5 นาที แล้วผมก็จะให้โซลูชันนะ ไม่ทำเยอะไม่ต้องให้เยอะ คือถ้าไม่ได้บอกว่าทำน้อยแล้วจะผ่าน แต่ว่าทำแค่นี้ที่เหลือไปหาทำตรงนี้จะให้คุณเข้าใจคอนเซปต์เฉยๆนะ พยายามไปทำเยอะๆถ้าอยากได้เกรดดีๆกันโอเคครับ โชคดีทุกคน ถ้าใครยังไม่ฉีดวัคซีนก็ทยอยไปฉีดนะ
ครับผ
เปิ
ม
ดเทอมหน้าจะได้เจอตัวเป็นๆกัน
ครับอาจารย์สวัสดีครับขอบคุณครับ
Thank you, sir.